Now we're going to continue with our pump and tube analogy for electrical current. And so remember, our battery is our pump, and I'll just draw a battery here. And there's the positive terminal, there's the negative terminal. And now I'll draw our circuit as a system of tubes. And so here's our tube. And remember, we put a constriction into this tube here. Let's analyze this and see what happens. Okay. So we can imagine all of our charged particles flowing. We want to just pretend that positive charges flow. And they're flowing through this constriction. What's going to happen, someone said it before, what if we measure, and if we're pretending that this is water, and we measure the pressure here, and we measure the pressure here. So let's say this side is going to measure 10 psi, for example. What do you think roughly the other side would be measuring? Anybody have a guess? It's on the negative side of your pump. The negative side is sucking these things back in.
Would it be a negative pressure?
Or zero.
Or zero?
Yeah. Just call it zero. 0 psi. Okay, so that's zero pressure. So there's a pressure drop from here to here. Anybody want to take a guess what the electrical equivalent of pressure is?
Resistance.
No. Yes.
Voltage.
Voltage. Okay, good. Good. So there is a voltage drop from here to here. So let's say this is a car battery. How many volts is a car battery?
120?
No. We're lucky they're not 120 volts.
12.
12 volts. Right. 12 volt battery. So the voltage drop, if you measure it from here to here, is going to be 12 volts. All right. And that's the equivalent of pressure in a moving fluid. Now, we can measure, so this is voltage, volts. And what's the other property or the other variable of the electricity we can measure? Yeah, Nicholas. Amperage. What's another word for amperage? Thaddeus, do you know? No? Okay. No? No, Andre?
I don't know.
Current. Current. Amperage is the units of current. Okay? So we can measure the current, and the current in a fluid is intuitive. It's how many cubic inches per minute or gallons per minute, to say that way. How many gallons per minute pass through this section of wire? So we'd measure, or tube. So we measure gallons per minute. That would be the current for a fluid. What would be the current what would be the actual current in an electrical circuit, Nicholas? No? What are we counting for current? What we're actually counting number of electrons per second. Yeah. So if we actually had an electron counter, and again, this is where here's our electron counter, and it counts the units of charge, which are called coulombs. I'll just write it like this: charge per second, and again in physics it's coulombs. See, coulombs per second, and this is directly proportional to the number of electrons per second. So you're literally counting electrons, how many pass in a second, and that's your current. But it's got this factor because a coulomb is many electrons. Many electrons make up 1 coulomb. So 1 amp is 1 coulomb per second. And you can actually calculate how many electrons that is. So current is the amount of charge per second that's flowing in your tube. Now, we can also measure this thing over here. This restriction in the tube electrically has a name. Anybody want to take a crack at it? What would that be called?
Bottleneck?
A bottleneck. It is a bottle. It's literally a bottleneck for electrons, and it's called a resistor. Oh, you should have said it. Too bad.
I did say.
It's a resistor, and resistance is measured in ohms. All right, with the symbol omega. When you say ohms. Ohms. All right. Now let's take all of these variables and draw them schematically and write the very simple equation, which is known as Ohm's law. All right, let's go to a new slide. All right, so I'm going to draw the same circuit, but this time I'm going to do it as an electrical schematic. So I'm going to draw my battery. And by the way, well, anyway, I draw my battery. Keep it simple. Positive, negative. And we're going to go through a resistor. That's the symbol for a resistance. And the battery is 12 volts, and the resistance is 100 ohms. And we want to find the amount of current in the wire. Now, this is very confusing because current, you have to keep in mind a couple different things. The symbol for current, when you draw this thing, you want to know the current is called I, lowercase I. But if you want to say how many amps of current you have, this you say, let's say the current was 10 amps. You'd write 10A. So you'd say I equals 10A. Nicholas, got it?
Right.
Right. Wake up. Okay. Current, I equals 10A. So you got to keep in mind I is the letter for current, but A is the symbol for amperage. A little confusing. You'll get it. It'll make sense once we do a few of these. So the question I have here is, what is the current in this wire? Well, we have to have the equation. So it's real simple. V, so voltage, equals current times resistance. V equals IR. And sometimes you'll see this drawn as a capital I in Ohm's law, but on a circuit diagram, you always draw it as a lowercase I. It's all convention, but if you want to be able to communicate effectively and look smart, you need to know the conventions. So, I don't know if that's anybody's goal in life, but I mean, it is for some people. But anyway, it's kind of fun to know the language. You know, it's like conjugating your verbs right. Anyway, so V equals IR. That's Ohm's law. Ohm's law. And there's a million different ways to write this. You'll see charts showing you every conceivable way of writing Ohm's law, depending on what you know about your circuit. We'll start with this just so we can get the feel for it. What are the two things we know about the circuit? Nicholas. What do we call the ohms? What do we call that? Okay, right. It's the symbol omega. Resistance. We know the voltage and we know the resistance. So real simple. 12 equals I times 100. 12 divided by 100 is what, 0.12 equals I. So I equals 0.12 amps. So it's 0.12 amps. And again, if you want to sound like you know what you're talking about, you convert this to milliamps. So you'd say 120 milliamps. Okay? Now, so that was easy, right? What if we know other stuff? What if we want to measure the voltage of the battery and we don't know it? But we have a current meter and we know the resistance. So now, let's say we know that this is a 1 ohm resistor. 1 ohm resistor. Well, we better stop. We'll go to the next video and do this because we're going to run out of time here.